Okay, section 2.4. We're still dealing with graphs and functions, but we're going to specifically deal with linear functions. So before we've dealt with linears and quadratics, rational, things that had fractions. The way you can recognize a linear equation is your x and y only are the power 1. Okay, so if you had something like, ax squared plus bx equal y, this is non-linear because of that squared term, okay? So if I have something like ax plus by equals c, my variables are x and y, they're only raised to the first power, that's a linear equation. So we're going to deal with slope you may have dealt with in lines before, how that talks about rates of change, and then a few word problems that deal with lines. Okay, we talked last time about function notation, f of x. So I can write a linear function as f of x equal ax plus b, okay? So this is a linear function. Lines, anytime you graph a line, it's going to go from negative infinity to infinity. So in these cases, your domain and range are both negative infinity to infinity. Now, let's talk about graphing lines, and you've probably done this in previous classes, okay? So graphing a linear function using the intercepts, okay? So let's look at f of x equal negative 2x plus 6, okay? Remember, you can find the x-intercept when f of x equal 0. Another way of thinking about that when you're graphing it, if your y is 0, they're finding setting y equal to 0 gives you the x-intercept. Setting x equal to 0 gives you the y-intercept. So let's set f of x equal to 0. 0 equal negative 2x plus 6. Negative 6 equal negative 2x. Therefore, x is equal to 3. So this tells me that the point 3, 0 is on my graph. Well, the y value is 0 there, so this is my x-intercept. Now, let's go ahead and find the y-intercept. So this is what we just did a moment ago. So to find the y-intercept, you set x equal to 0. So the y-intercept, you're going to set x equal to 0. That means figure out what f of 0 is. F of 0 is negative 2. You're plugging in 0 for x. So f of 0 equals 6. And so now I have 2 points that are on the graph. So I've got the point 3, 0 that I found just a moment ago. And hold on just a second. So let me just draw a new graph here because you'll be graphing it. The point 3, 0, that was the first point that I found, and the point 0, 6. Those were my 2 points. If I connect these like so, that is the line negative 2x plus 6. So that was a way of finding the intercepts. If you set x equal to 0, you're finding the y-intercept. If you set the y or the f of x equal to 0, you're finding the x-intercept. F of x equal negative 3. So remember, f of x is just a way of saying y. This is the line y equal negative 3. So what it is saying is your y values are always negative 3. Look at your y-axis. Where is negative 3? It is right here. What line has y values always equal to negative 3? That's the horizontal line that you see right there. What is the domain of this line? The domain is from negative infinity. Remember, that's the x values, from negative infinity to infinity. What's the range? The only y value you ever see in this graph is negative 3. The range is -3. Let's look at graphing the line x equal -3. X equal -3. Look at your x-axis. Find -3. Here it is. What line has values that are always -3? That is a vertical line. So a vertical line you see here, x equal -3. What is the domain? The domain, there's only one x value. The domain is just -3. And what is the range? The range of this is -infinity to infinity. Your y values start at -infinity and they go up to infinity. So we've graphed the vertical line there. We will talk about a line being in standard form if we can write it ax plus by equals c. So ax plus by equals c. The other form that we talked about was f of x equal ax plus b. Okay, those are just two different ways to write the equation of a line. This one is in function notation right here. And the next one is just what we call standard form. The nice thing about standard form, it's pretty easy to find the intercepts. So let's look at the example they have below. 4x minus 5y equals 0. So 4x minus 5y equals 0. Let's just say, basically we're picking points here. What happens if x is equal to 0? Okay. If x is equal to 0, that's finding the y-intercept. If x is equal to 0, you get 4 times 0 minus 5y equals 0. Well, this is 0. It says negative 5y equals 0. That means that y is equal to 0. So I know that 0, 0 is on my graph, okay? Now, remember when x is 0, that's the y-intercept. When y is 0, that's the x-intercept. This is the x and the y-intercept. So that tells me that my graph goes through both of those points. So if you look at it, I know that when I start to graph this, 0, 0 has to be on the graph somewhere. Now, I just need to pick another point. Okay, so I've got 4x minus 5y equals 0. Let's just pick a number that's easy. What if x were equal to 1? So if x is equal to 1, I get 4 minus 5y equals 0. 4 equal 5y. Y equal 4/5. So that tells me the point 1, 4/5 is on my graph. So if I go over 1, 1, so not quite 1, so somewhere right in here is going to be the graph of this line. Now another concept about lines is the slope. Think of a roof, it's the pitch. You know, how steep is it? You might hear the word rise over run. It's the difference in the y's divided by the difference in the x's. Okay, so let's just do a few examples of this. The way you'll figure out, if you've got 2 points that are on a line, the slope is the difference of the y's over the difference of the x. So we talk about, a roofer might say it's the rise over the run. This delta just means difference. The change in y or the difference in y, change in y over change in x. So what's the change in y? You would just say, what is this y value minus this y value divided by the x value minus the other x value. So it doesn't matter which one of these you start with, x2 minus y2 minus y1, or y1 is y1 minus y2. You just have to be consistent. So let's do a few examples of calculating the slope. So let's find the slope that goes through a line that goes through these 2 points. So I've got a line that goes through these 2 points. We usually use the letter m for slope. So it's going to be the change in y over the change in x. How are the y's changing? So look at your y values. 8 and negative 3. So it's going to be 8 minus negative 3. Change in x. That's going to be negative 4 minus 2. Negative 4 minus 2. So on the top, this is just going to be 8 plus 3. And down below, I have negative 6. So this is 11 over negative 6. That is just the slope is negative 11, 6. So this is a line that has negative slope. Find the slope of the line going through these 2 points. Okay, so if I look at this, the point 2, 7, 1, 2, 1, 2, 3, 4, 5, 6, 7. That's right there. 2, negative 4, 2, 1, 2, 3, 4. So this is a vertical line. I'm trying to figure out the slope. So the slope is going to be the change in y. So that's 7 minus negative 4 over change in x. 2 minus 2. So this is 11 over 0. 11 over 0 is undefined. So this slope, this is a vertical line. So vertical line, the slope is undefined. Let's look at this one. Find the slope of the line that passes through these points. Okay, the slope is going to be the change in y, negative 3, minus negative 3, over 5, minus negative 2. This is 0 over 7, which is 0. So the slope is 0. So what does this line look like? We can plot these 2 points, 5, negative 3, and negative 2, negative 3, right here. This is a horizontal line. So the slope of a horizontal line is 0. It has no slope, okay? The slope of a vertical line is undefined, which is different than no slope. It is undefined. So a horizontal line has a slope of 0. Now let's look at solving this and figuring out the slope of this particular line. Now, what we want to figure out is that you've got ax plus by equals c. That's our standard form. The slope-intercept form of a line is all you get. Basically, that's just a fancy thing for solve for y. So when you solve this for y, you're going to get y equal mx plus b. This will give you your slope, and this will be your y-intercept. So let's take this equation, solve for y. So 4x plus 3y equal 12. Subtract 4x from both sides. So 3y equal negative 4x plus 12. Divide everything by 3. So that tells me that this is a line, and you can read it straight from the equation. Slope is negative 4/3, and the y-intercept is 4. So in this case right here, I've got slope negative 4/3. My y-intercept is 4. That means it goes through the point 0, 4. Now we can use that kind of information to graph a line, okay? Graph the line that passes through this point and has a slope of negative 5/3. So I'll need to find the point negative 1, 5. Here's negative 1, 5. Now what the slope is, remember the slope is my change in y over change in x, okay? So that means that looking at this, if I were to go negative direction of y, negative direction of 5, change in y, 1, 2, 3, 4, 5. If I go negative 5, I need to go over positive 3. 1, 2, 3 right here. So this is negative 1, 1, 2. So if I go down 5 and positive 3 this direction, I'm back on the line. So that is this particular line. So you're using the slope because you know that this is going a negative 5 direction. This is going a positive 3 direction. You're reading that straight from what the slope is, change in y over change in x. And that tells me this point right here, 2, 0, has to be on the line. And that's the one that we just did. What you would know about slope is this is what it means to have a positive slope. This is what it means to have a negative slope. This is what it means for the slope equals 0. Okay. Now we're also going to use terminology called rate of change. Rate of change is just a fancy word problem terminology for the slope. Okay. So if my line represents, subscribers to, Netflix, if I've got a line that represents that kind of problem, the slope is going to be embedded in that. So like the slope is not just slope equal 4, it'd be like, oh, it's the rate of increase of subscribers. So we'll work a couple of problems and you'll see that come into be here. So let's look at this. In 1980, the average monthly rate for basic cable was $7.69. In 2008, the average monthly rate was $46.13. Assume a linear relationship and find the average rate of change in the monthly rate per year. Graph it as a line segment and interpret the results. Okay. So what I need to do here is figure out, okay, they're giving me a problem that says I'm starting out my data in 1980 and I'm going all the way to 2008. So I know that in 1980, the average rate was 769. And in 2008, that rate was 46.13. So that tells me that my graph has the point 1980, 769. That's 1 point on my graph. And then 2008, 46.13 is another point on my graph. So what I need to do is just figure out drawing a line between these two, which is what you see there. So I've got a linear relationship that tells me what this is. So they're asking me to find the average rate of change in the monthly rate. That's just a way of saying find the slope. Okay. So if I look at the slope, what is the slope of that line going to be? The slope of that line is going to be change in y. $46.13 minus 7.69 divided by change in x, 2008 minus 1980. That's going to be my rate of change. So if I do this on my calculator, let's see, 46.13 minus 7.69 equals 38.44. Over 28. So 1.07 or 1.08. So the slope of that line is 1.08. But here's where you got to put it in context of what this is. This represents the dollars in my monthly cable rate. This represents years. So that tells me on average, the rate of the cable went up $1.08 per year. So if you look at that, and I must have done this wrong, 38.44 divided by 28. Did I do this wrong in my calculation? Sorry about that. 38.44 divided by 28. I must have typed it in wrong. Yeah, 1.38. So this number is 1.38. The answer to this problem is the average change is, it's a dollar and looks like $1.37, 1.372. So it's a $1.37 increase per year. Okay, so all you did was find the slope. The slope is 1.37, but interpret the slope in the context of the problem. So it says, on average, we expect this cable rate to go up about $1.37 per year every year. So we'll end with another couple models here. This is a model that talks about cost. Okay, so cost function. Remember we talked about cost and revenue. And I may have another model that deals with revenue. So I've got a revenue function. Now, what I'm interested, if I've got cost and revenue, is I'm interested in profit. So if C of X, if that's my cost, and if R of X is my revenue, you know that profit equals revenue minus cost. Okay, so we're just going to do a problem that deals with that with linear functions. So let's take a look at an example. Assume that we have a cost model to produce an item. The fixed cost is $1,500, the variable cost is $100, and the item sells for $125. Write the linear functions to the model. Okay, so in this one, my fixed cost is $1,500. My variable cost per item is 100. So this gives me a cost function of 100x plus 1,500. Now, how do I get the revenue? The item sells for 125. So that tells me that the revenue is just going to be 125 times x. Okay, so I've got the revenue is just 100, what I sell it for, times the number that I sell. So how do I find the profit? So remember, my cost in this case is going to be 100x plus 1,500. My revenue is 125 times every one that I sell. My profit function, profit equals revenue minus cost. So in this case, my profit function equals revenue minus cost. So this becomes 125x minus the cost of 100x plus 1,500. So 125 minus 100, so the profit is going to be 25x minus 1,500. So that is a linear model for the profit equation in this. Now, how do I determine where I make a profit? Okay. So if I look at it, I've got a profit function here. Making a profit means I make money. So I got to figure out where is my profit greater than 0. So that means that 25x minus 1,500, when is that greater than 0? Well, that's when 25x is greater than 1,500. I can divide everything by 25, and I get x is greater than 60. So it tells me that if I make 60 items, I break even. So I've got to make 61 to make a profit. So you got to make, you can either say it this way, more than 60 or you can say 61 or more. Those are the number of items you must make in order to make a profit in this particular model. Okay, that should be it for 2.4.